Yesterday we have considered the classification of collisions. In that respect, we have defined elastic, inelastic, plastic collision, distinction between them, and also we have defined impulse of reformation, impulse of deformation. Today we are going to concentrate on head-on collisions. In this head-on elastic, inelastic, plastic collision, and take examples and how to calculate the impulse of deformation, impulse of reformation. So, yesterday we have in the head-on elastic collision case, we have written the expression final velocities of colliding bodies as m1 minus m2 by m1 plus m2 into u1, where u1 and u2 are the initial velocities of the bodies, m1 and m2 are the mass of the bodies, 2m2 u2 by m1 plus m2. And similarly, v2 we have calculated as 2m1 u1 divided by m2 plus m1 plus m2 minus m1 by m2 plus m1 into u2. So, this once you are able to write the first equation by changing the interchanging the subscripts, we will be able to write the second equation. This equation is valid or can be used for head-on elastic collision. Head-on elastic collision only it is valid. So, in this case, various cases of depending upon the relation between the masses, depending upon whether the second target body, this second body is called target body, first body is called incident body, one of them is at rest. So, first case we consider for m1 is equal to m2 is m. Two bodies are identical and assume that target body is initially at rest, that is a body moving towards another body, identical body which is at rest. In this case what we get is v1 is equal to 0 and v2 is equal to u1. Means what? First body which was moving comes to rest and the second body takes up the velocity of the first body before collision, means it is going to transfer its velocity to the second body. This is the case. Now, if u2 is not 0, for u2 not 0 case means target is not at rest, what we get for the same m1 is equal to m2 and m, we get v1 is equal to u2 and v2 is equal to u1. They exchange their velocities. In the case of head-on elastic collision between identical bodies, the velocities after collision are simply exchange, means first body comes out with velocity of the second body comes out with velocity of the first body. This is first conclusion. For example, a body of mass 4 kg is moving with a velocity 2 meters per second and another body of 4 kg mass moving with 4 meters per second. Okay, this is call it as A and B. Before collision, these are the velocities. And assuming that the collision is taking place along the line joining them, therefore it is one-dimensional elastic collision or head-on elastic collision. Then after collision, we can straight away write this body A now starts moving towards left with 4 meters per second. The first B body, the body ball B, which was moving towards left, will now move towards right with 2 meters per second. Simply exchange of velocities. That is about the head-on collision, elastic collision. Now, another simple case is based on this idea. We have two balls, identical balls, B and C are at rest and A which is all these are identical. M, mass of this is M, mass of this is M, moving with a velocity u, at rest initially, that is before collision. Before collision, these are the velocities, means A is moving with a velocity u towards B and C, both of them are at rest before collision. Now, how to calculate, how to decide after collision what is going to be the velocity of these bodies? First, we can consider that first A is going to collide with B. When A is colliding with B, A comes to rest because these two are identical bodies. Collision is elastic, head on. Thereby, A comes to rest. After collision, A comes to rest. A will be at rest. Then what happens? First, it will transfer its velocity, exchange the A and B collision, B will be getting the velocity of A. Then what happens? B now moves towards C and makes a collision. Finally, after final collision, B comes to rest. B will be at rest. Means first B takes the velocity of U, then transfers its velocity to C. Finally, A is at rest, B is at rest, and C now will be moving towards right with a velocity U. So, this is after collisions, two collisions between A and B and between B and C collisions take place. After collision, C will be taking up the velocity of A finally. But before the collision, B is at rest. After final collision, B is still at rest, but C will be getting the velocity of A transferred to it. Similarly, another example, we can take a simple example where the velocities are exchanged. So, we consider two bodies, mass M, this also another mass A, ball B, both are of same masses, moving with velocity u. This is at rest, B is at rest, and C is also at rest, and D identical ball. All balls are identical. D, whose mass is M, started moving with velocity u, and all are along the same line, and collision is elastic collision between them. What happens after collision? Finally, this is before collision, this is situation. After collision, what happens? A collides with B, transfers its velocity to B. Now, B starts moving towards right, and D collides with C, and C will be moving towards right. Then collision between B and C takes place. After collision, what happens? Because these two are identical bodies, C velocity will be transferred to B, B velocity is transferred to C. Then after that, what happens? Earlier B was at rest, first collision case we will say. First collision takes place between A and B here. Therefore, A comes to rest and B starts moving with velocity u. First collision between these two. C starts moving towards left with velocity u, D comes to rest. D will be at rest. Okay, D will be at rest, C will be moving towards right. This is first collision. First collision between A and B, first collision between D and C. Next, what happens? Now collision between B and C takes place. Then after this collision, what happens? B now moves back because it will take up the velocity of C. Now moves back with velocity u, and C turns back with velocity u because there is exchange of velocities. C will be moving right this. Then D is at rest and A is still at rest. This is next collision between B and C. Then afterwards, what happens? There will be a collision between B and A. Then after this collision, it is going to be identical balls. Therefore, B will be transferring its velocity to A. Finally, what we will have is A will be moving towards left with a velocity u, B at rest, and C at rest, and D now moving towards right with velocity u. After 2-3 collisions among the colliding bodies, simply the A and D, they move in opposite directions and both B and C are at rest. This is the head-on collision. Now, in the head-on elastic collision, how to calculate the deformation of impulse, reformation of impulse, impulse reformation, impulse deformation. What actually happens between two bodies is, say this is one body and this is another body, m1 moving with velocity u1, m2 moving with velocity u2 along the same line. We are talking about head-on collision and elastic collision we are considering. This is before collision, they are moving in this direction with u1 greater than u2. Means ball m1 is colliding with ball m2 from behind. Now this is before collision. Then after collision, what we observe is, after collision takes place, the velocity of the ball m1 mass, let us assume that becomes v1 and m2 ball velocity becomes v2. This is after the collision. After the collision, these are the velocities. Now this and this, during this time when individually before collision, after collision, there is no interaction, but during collision there is going to be interaction. What is going to happen? During the collision, the bodies start experiencing, assuming that there is a physical touch, deformation takes place during the collision. During the collision, the ball A will experience deforming force towards left. That is, first ball will experience deforming force towards left, exerted by the second ball. Therefore, first ball shape is going to undergo change because of deformation. The reason is ball m1 is supposed to be possessing some elasticity. Therefore, deformation takes place. And because of the deforming force acting towards left on the first ball due to second ball, the velocity of the first ball goes on decreasing. And how long it will decrease? During that velocity decrease, because of the deforming force, ball m1 undergoes deformation. It is undergoing deformation, and also because of that force, velocity goes on decreasing. Therefore, deformation goes on taking place for up to a certain extent, where the ball undergo maximum possible deformation. Beyond that, it will not be able to undergo deformation. During that transition time, the velocity of the first ball is supposed to be changed to v. That is a velocity where the ball has decreased from u1 to v. The ball velocity has decreased because of the deforming force and by impulse of deformation, and final velocity of the ball at the end, at the maximum deformation case, when the ball undergoing maximum deformation, the velocity is changed to v. It is less than the velocity u1. Similarly, during collision time, the second ball also will be experiencing deforming force towards right. So therefore, the second ball also, it was initially moving with velocity u2, because in that direction the deforming force is acting on m2. Therefore, impulse of deformation is acting on m2 towards right, both impulsive force and impulse of deformation. Therefore, velocity increases from u2 to same velocity as that of first ball at the time of maximum deformation. This is at the time of maximum deformation. During maximum deformation, both the bodies are going to be touching each other. They are going to be touching each other, and both undergo maximum deformation, and both will be moving together with common velocity. This is during the interval, that is during the interval from 0 to maximum deformation takes place. This is called collision time of deformation. Next, what happens? Now both the spheres are under maximum deformation, then because they are possessing elastic property, they will try to restore to the original value. Therefore, what happens? This will try to experience a force in this direction, body will try to come back. Therefore, restoring forces will act in this direction, increasing the velocity to V1 and decreasing the velocity to V2 for the second. Therefore, before during deformation, what happens to M1? M1 was moving with velocity U1 initially and experiencing deformation impulse JD in this direction towards left, because the second ball is pushing it towards left, and finally at the end of deformation, final velocity becomes V. Therefore, we can write minus JD is equal to M1 V minus U1. This is what we write for the equation of deformation impulse equation. So, therefore, JD we can find. Minus JD we are writing because initial momentum, final linear momentum of the ball is in the forward towards right, but it is experiencing impulse of deformation impulse towards left. Therefore, minus JD is equal to M1 times V minus U1, or JD now equal to M1 into U1 minus V. This is the impulse acting on the first ball.